episode of Oracle Mobile Cloud Service, we're going to investigate the data offline and sync capabilities, specifically around data update collision detection and resolving this. G'day, I'm Chris Muir from the Oracle Mobile Platform team. Imagine the scenario where a mobile user has downloaded objects from MCS and cached the objects locally. The mobile user then updates one of those objects, but on writing the updated object back to MCS, we discover another user has beat us to it and updated that object before us. So, whose update wins out? Do we simply overwrite the server's copy? Do we reject the client's updated object? Or is there a compromise to merge the objects? With the data offline and sync capabilities, we refer to this scenario as collision detection. And then how it is resolved is surprisingly known as collision resolution. Simply put, for MCS, collision detection is the act of detecting when one mobile user update to an object is overriding another user's update to the same object on MCS or on the server. So how does this work? When fetching an object from MCS, the client SDK also takes a copy of the object's E tag. On submitting the updated object back to MCS, your server-side custom API code compares the E tag from the client against the current E tag of the object on the server side. Now, if the E tags are the same, that means nobody has updated the server object, and we're fine to write the client's change over the server's copy of the object. However, if our server-side custom API code finds different E tag values, it knows that the server-side object has been updated since the client took a copy of the original object and its original E tag, and therefore a collision has been detected by the server. Once this occurs, collision resolution is where your server-side custom API code reports back to the client SDK that it has discovered a collision. And then the client must decide how the collision should be handled on the client side. So what are the options for collision detection and resolution provided by Oracle Mobile Cloud Service? Well, there are basically three options you can set on the client. The first option, client wins. During writing an update to the server, the change object on the client will always overwrite any changes discovered on the server. From the client's perspective, it's always going to be happy with this outcome because it got its own way. The server wins option is the opposite. During writing an update to the server, changed objects on the client will be overwritten if any changes are found on the server. And it's important to note here there is no recourse. The client's updates lose out always. Now both options are useful but somewhat definitive from either the client's or server's perspective, you would agree. Is there a more flexible option in between? Well, the preserve conflict option says during a server update, objects on the client will overwrite server objects only if they've not changed since they were last fetched. Otherwise, the client will programmatically resolve the conflict. Setting the policy is quite simple. As we can see here in an example from iOS in its own CPList file. In this example for Mobile Custom Courier, the API, we've set amongst the other policies the conflict resolution policy to preserve conflict. Now you've got an idea of the broad capabilities and options, stick with us and check out the next three videos that explain how each option works in detail, and very importantly, what you need to code in your custom APIs to support each option. Thanks for joining me. Hope I'll see you in those next three episodes very soon.